live stream. Just an FYI that you can join the Zoom and ask questions. We aren't going to be monitoring the Facebook live stream during the event. I'll check it after if folks have questions, and then I'll go in there and, you know, get in touch and things like that. But if you are watching on Facebook and you want to ask us questions live, you still have time to join the Zoom. You can go to bit.ly, so bit.ly/ClimateCast live, and you can find the Escambia County webinar there. And it looks like our audio is still coming in loud and clear, which is great. We got 1 minute till we get started. We're just giving people a chance to come on in. For those of you who just joined, thanks for getting here a minute early. Feel free to say hi to us in the Q&A. I'm here with Carrie, my colleague from Escambia County UF IFAS Extension. We're going to get officially started in 1 minute. So just hang out until then. Yes. Mom, oh yeah, my mom wants to know, does the camera look good? What's going on, Mom? Here, you can shout it out. We haven't officially started yet. Everything's good, Mom. All right, we'll be right back. We're getting started in 1 minute. Hey, everybody. We have our encrypted camera person over there with my mom, which is great. It looks like the audio is still coming in loud and clear, and we're right at 4 o'clock Central, so I say we get started. Hello, everybody. My name is Caroline Nickerson. I'm a PhD candidate from the University of Florida, specifically the University of Florida's Agricultural Education and Communication Department. I'm also associated with the Streaming Science Project. And with me is Carrie from UF IFAS Extension Escambia County. Thanks for being here, Carrie.
Yeah, my pleasure.
Awesome. And Carrie's our expert speaker for today. Before we get into it, some quick housekeeping. I just wanted to make sure that we thanked all our partners before we really got going. So we received support today to put this on from the North American Association for Environmental Education, as well as SciStarter. Thank you to them. IC Change is a citizen science project that also agreed to partner with us. Of course, we got UF IFAS Extension, my department, the Agricultural Education and Communication Department, and Streaming Science. So thank you so much to all the partners and supporters who made this happen today. This event is also part of my PhD research. So if you all want to help us out, you can do a survey at the end. We'll have the option to drop a survey in the chat. And if you fill out that survey, you know, it's not mandatory, obviously, but it's really helpful to me. I think it's a lot of fun. It helps us understand how programs like these impact people's understanding of the environment and climate change and topics like erosion. So I really hope you all do fill out the survey. And there's also the option to do interviews too after the event. And this is the second in the series called ClimateCast Live. I'm going on tour throughout Florida. So yesterday I was in Sarasota with Armando from Sarasota County Extension. Today I'm here with Carrie in Escambia County up in Pensacola. And then later this week I'll be in Miami-Dade, and then next week Brevard County, so you know Cape Canaveral specifically, and Monroe County, I'll be in Key West. So tune into those two, even if you're not in that county. You might be interested in some of the topics we're spotlighting, including stormwater, trees, and electric buses, all related to climate change. And then, oh, someone asked a question. Let's see. Where's the streaming on Facebook? It's going to Streaming Science's Facebook page. So the recording is available at facebook.com/streaming science. I'll also be, after the program, adding it to the Streaming Science website via that ClimateCast Live link you can see on the screen. And once again, the research isn't mandatory, but if you do the survey after, I'd be very grateful. And I think it's a great thing to do. All right. So Carrie is our expert today, so I'm going to let her give us a little bit of framing about climate change before we get into some of our demos and stop sharing our screen and show you the dunes. But first and foremost, let's get some background.
All right, thanks. So I'm going to just jump right into the data. Climate change is happening, whether we like it or not. And we have proof. We have scientific proof. We have been keeping record of this worldwide since 1880. So we've got 140 years of data on climate ranges, highs, lows, and daily totals. Now we've got NASA and NOAA keeping track of this using satellite technology, using tidal gauges all over the place. Good news and bad news on that. Mostly bad news, unfortunately. 2023 was the hottest year globally on record since we've been paying attention since 1880. Last year was the hottest year globally. It was also the lowest amount of polar sea ice. That polar sea ice helps regulate the global temperatures, and because it was so hot, the sea ice could not freeze the way it normally does. So it was the lowest amount. If you look at Armando's recording from yesterday, he's got some images of those polar ice caps. Second hottest year on record was 2016, so in the last decade. And unfortunately, the 10 warmest years since the 1800s have occurred between 2010 and now. So that's the last 14 years have been the hottest years that we know of. So we are dealing with this. This is real, and it's continuing to go up, unfortunately. So, one of the things that we hear a lot are people who, in the middle of the winter, we have a warm day, or in the summer, we have a cool streak. And people are like, there's no global warming. Look, it's so nice and pleasant when it should be not really cold, or it's really warm in the middle of the winter. But weather and climate are not the same thing. When people talk about what it feels like right now, they're talking about weather. So weather is short term. It's what's happening today, what's happening this afternoon. If you've lived in Florida for more than 10 minutes, you know that the weather can change quickly. It was sunnier early today. Now it's completely overcast. It may rain tomorrow. It may stop. And it's limited area. A couple miles from here, it could be completely different weather and temperature. It can be difficult to predict. As anybody who's watched the Weather Channel knows, they'll tell you one thing, but it may not exactly happen the way they predict. So weather is difficult. It's short term. It's constantly changing. So weather is what's happening outside right now. But climate is different. It is long term. It is not a day or an hour. It is months and years and decades and centuries of patterns. It's from a broad area. It's the whole state of Florida. It's all of Northwest Florida. It's the whole southeastern United States. It's when the seasonal changes happen, when we predict spring will come, when we think winter is going to come, when plants start coming out and blooming. It's measured again in decades and centuries. And it's an average of many years of weather observation. It's not just what 1 year does, because you can have anomalies every few years. It's what happens over time. One good example I've heard is that weather is what you have, the clothes you have on. Climate is what you keep in your closet. If you live in Florida, you're going to stock it with shorts and flip-flops. If you live up north, you're going to have a lot of jackets. While you may need a jacket in Florida sometimes, you may need flip-flops in Wisconsin every now and then. For the most part, you're going to have a type of climate that you can predict. And that's what we talk about with climate and climate change. It's not just year to year, it's decades.
That's good to know.
So what does that have to do with sea level rise? Well, so oceans are constantly expanding. They are rising around the world. And the reason for that is that even if we have the same amount of water, the volume expands as the oceans are heating up. So if you see in this Charles's law description here, you've got the same amount of water, but as the temperature heats, those molecules move and the water increases in volume. So the seas rise because they're heated up. So that's one source of rising water. You have the same amount of water behind me, but it rises because it's hotter. The other is melting of land ice. So those glaciers, the ice caps that are up on top of mountains, on landlocked valleys, when they don't freeze and that water melts down, added to the existing oceans, that adds volume to the seas as well. So those are the two main sources of sea level rise.
And we actually got a question about sea level rise.
Yeah.
Anonymous attendee wants to know, how can we combat sea level rise?
So we're gonna talk about that. There's it's a big effort, right? There are individual things we can do that we'll talk about, but it's got to be large scale reduction of fossil fuels, reducing the amount of carbon dioxide in the atmosphere. It's using renewable energy. It's eating closer to the food chain. It's driving less. There's so many things that we can do. But again, it's got to be it's a group project, right? And we know how group projects are. Some of us do a lot of work and others don't. And so It's one of those things that as science, progresses, as people understand more and they see the things that are happening, we can respond. And we'll talk about some of the things that have been done, but there is more funding for combating climate change and for adapting to it, because honestly, some of the things we can't turn back. We're just going to have to adapt to over time.
Good stuff.
Thanks.
Yeah.
All right. So kind of back on my science here. This is looking at global average sea level from 1880, again, when we started taking serious measurements on tide gauges and then satellite joining in once that technology was intact. So that's from 1880 to 2014 that you're looking at. In 1880, if you have the sea level is 0 there, if you look at that upward trajectory, you've got an average of about 9 inches in sea level rise from 1880 to 2014. So again, that's globally 9 inches. Interestingly, we are seeing the exact same pathway and pattern here in Pensacola. It's a little bit different chart because it's in metric version. But if you look here, starting in the 1920s, so 100 years of data. This is from a tide gauge at the Port of Pensacola that's been in Pensacola the last 100 years. We've seen 9 inches of sea level rise in our bay, just like we've seen worldwide. Now, the thing that is of major concern is this new chart here, where we've got that steady rise over the last 100 years, but in the last 12 years, we've gone, instead of a 12th of an inch per year, we've gone a half an inch per year. So since 2010, we've had 5 inches of sea level rise off the coast of Pensacola. That is a serious concern. The Gulf of Mexico is staying hotter than other bodies of water. If you think about it, we're more enclosed. We can hold more heat. And so we are rising at a faster rate than other places around the world. And so this is a real concern. This is new NOAA data. There are a lot of papers coming out about this right now. And unfortunately, this is the trend we're seeing. And so we're going to have some pretty serious impacts from this. So to continue the good news, sorry guys. So and I'm really an optimistic person, but I've got to kind of tell it like it is. So in addition to sea level rise, for the last 10 years, most of the predictions I've seen with increased global temperatures and impacts from climate change are that we're not necessarily going to have more hurricanes in the Gulf or more natural disasters, but they're going to be more intense. We already have a lot of storms in the Gulf. We're just a really, popular, busy area for that. But if you look at the records in the last few years, these storms mentioned here, I don't even have Michael listed, but Harvey, Nate, Irma, Maria, these were category 4 and category 5 storms. Michael was category 5, was one of the strongest ones we've seen. Ian, I think, got into the 4 or 5 range as well. These are devastating hurricanes, and because the Gulf is hotter, they create more energy in these storms, and they just sort of self-perpetuate and build themselves up. Another example is that because they're stronger, they're off, and you've also got more moisture in the air. As you have a warming climate, you can hold more moisture in the air, so it becomes rainier. Hurricanes are going to have higher rainfall rates in addition to being stronger in velocity. So one of the examples is Hurricane Harvey that centered on Houston and southeast Texas. They had 6 feet of rainfall over several days, and it just continually perpetuated that during the storm. Locally, data has shown a major increase in annual rainfall locally. We are a really, really rainy area in Escambia County, Northwest Florida in particular. We average about 65 inches of rain a year. We have for decades, but our averages are getting closer to the 70s because we've had so much rain. The Stormwater Advisory Team that was formed in 2014 after we had some really intense rainstorms found that we average a storm that used to be considered a 100-year storm. We'd only get that much rain every 100 years. We've had 4 of those in the past 80 years. So what used to be a 100-year storm is now basically every 20 years. This stresses our stormwater infrastructure. They were designed for smaller volumes of rain and less frequent, and so updating that is expensive, but much needed. Another thing that's tied into our stormwater system, you'll probably talk about it with the next ClimateCast in a few days, is we have an increase in nuisance and sunny day flooding statewide. And that's when you have sea levels that go into the streets on a sunny day. You get flooding during a time when you don't even get rain. And what happens is you have stormwater drains that go out into the bays, and as the tides rise and the sea levels rise, they go back up those storm drains and into the streets. And so you have this flooding on a sunny day, and there's nothing you can really do.
Wow. And I mean, so we have a question related to this from an anonymous attendee. They want to know, they're curious. They're like, warmer water increases the intensity of hurricanes. Could you explain that to us a little bit?
Yeah. So the hotter the Gulf, the stronger the storm. It's basically it's complicated and it would take longer than I have right now. But essentially, it's that warm water is essentially fuel for a hurricane. I can post an explanation of kind of how a hurricane forms later in some of the notes that Caroline sends out. But the hotter the Gulf is, the stronger the storm. It is fuel for that. The currents generate those wind velocity starts spinning more when you have those stronger heat differentials. And so, yes, hotter weather brings stronger hurricanes.
And so, FYI, everybody, Carrie has a weekly blog. I'm thinking the science of hurricanes might be a good featured blog topic.
Yeah, I've done it. Actually.
You've done it? Okay, been there, done that. There you go.
I can send that out. Yeah.
Okay, we'll link it in the follow-up email. That's fantastic.
Yeah. So our featured hazard for this program is erosion. Now, erosion is natural. Erosion is the movement of sediment due to wind and rain and currents and that sort of thing. That's part of being a barrier island. We are here on Pensacola Beach. It's absolutely beautiful, and it is a barrier island. It is made of quartz sand that got moved down from the Appalachians, down the Apalachicola River, and it moves westerly along the longshore current. So that sand for eons has been eroded from one area, moved through the currents, and deposited somewhere else. So that's just the way barrier islands work. That's a natural process. However, that erosion can be accelerated if you have intense hurricanes, if you have sea level rise, if you have human activity in those really volatile, constantly changing dune and beachfront areas. So, for example, a typical barrier island here on this chart, this is from USGS of Ship Island, which is off the coast of Mississippi. It's a barrier island. You can see the blue coloration is the former shape of the island from the 1840s. So it was further south and further east. This is a north-south orientation on this slide. So as you can see over time, as you move from blue to green to yellow to orange, that island has moved north, and it has also moved west. You see the tan color from 2005, that's further west. So northern Gulf Coast barrier islands, this is the typical shape. This island I'm standing on is the same way. It tapers on the east and it builds to the west because that longshore current is moving sand this way, and the Gulf is moving it north. So this is a typical shape of a barrier island, and this is, what it does. The problem comes when we have infrastructure on these islands. We create what's called coastal squeeze. So these are cross sections of an island. If you look at letter A up top, you see the seagrass on the far right. That's your submerged aquatic vegetation that's under the Gulf or in the bay. And you might have mangroves if you're down in the tropical areas. You have salt marshes if you are in northern, more temperate area. And you have beaches and dunes. So again, we're standing on a beach and we have this dune that is sort of protecting the forest that is able to establish to the north of us, because those dunes stabilize us from those immediate impacts of the constant incoming waves and tides. So in B here, in this cross section, the sea has risen. You can see there's more water and it's moved inland. So the seagrass, because generally sea level rise and incoming tides are a slower process, so the vegetation has a chance to move inland. And that's normally what would happen. The grasses, the marsh vegetation, the beach, the dunes, they just migrate inland, just like we saw in that slide of Ship Island. Island moves north. But if you have, like in C here at the bottom cross section, you've got a road there between the salt marsh and the forest. What's missing? You see the dune is no longer. So we have the rising sea, we have the vegetation trying to move inland and slowly migrate up, but then it hits a hard surface. It hits a road, it hits a building, it hits something that it can't move past. And so eventually all of this sand on the bottom will start to erode away and it'll just have a drop off. You'll have the road and it'll be directly into the Gulf. And so having these healthy dune systems that are not completely eroded away is crucial if you want to maintain any kind of barrier island.
My goodness, coastal squeeze. And then Christopher actually put something in the Q&A. He was talking about all the inches of rainfall that the hurricanes have given us. And that makes me think, looking at, the concept of coastal squeeze, what happens to this when there's a bunch of rain? Does the whole thing just get covered by water?
Yeah. So you've got flooding coming from both directions, right? You've got sea level rise and storm surge, which moves the water level up. And then you've got inland flow coming through the other direction from the rain. And so it's compound flooding. That's the definition of compound flooding, when you have it basically coming from both directions. So, storm surge is one of those things that is really, really dangerous because it increases the chances of flooding and heavy impacts from storms. So we have an example of where we had some coastal squeeze happening here on Pensacola Beach. Fort Pickens Road is just to my north here, and Fort Pickens is over here. And this is a long stretch of beach with very few buildings, only at the far west end. And again, this is the building side. This is the area of the beach that is building up because it's on the west side, and the longshore current is bringing sand that way. But we also have that movement to the north, right? We have the Gulf rolling the island to the north. So you see this road down here at the bottom was getting closer and closer to the Gulf. It was being impacted. Every time we have a tropical storm or a hurricane, the road gets damaged. They'd have to close it off. Nobody could go to the fort. So they put in a ferry service, so there's an alternative way to get to this national seashore in the historical areas that are there. But then they did something more dramatic. So years back, they moved that road from the south side to behind a dune so that it was further away from the Gulf that was encroaching on it. So this is one way that you adapt, right? You retreat from the coast. We're still on the coast, but you retreat from the immediate beachfront so that you don't have those impacts right on an important piece of infrastructure. Another example is just over the state line over at Dolphin Island, Alabama. This view shows, again, also the west end of the island, again, where you have more of a building, more sand coming in, but you've got these houses on the Gulf side that are protruding out into the open Gulf. At one point, there was a significant beach in front of these houses, between the houses and the water. But just like in our cross-section example, we had rising seas, we had coastal squeeze, and there was nowhere for the sand to go. So it just went around, it eroded to the edges. They have seawalls that are keeping those houses intact. But the beach wants to be where it is on this forward side of the slide. If you have a hurricane hit this area, these houses are going to be completely devastated. You may notice also there's not much of a dune system here. It was either damaged by man-made construction or from a storm, but there's not any dunes protecting these areas, and so there's no natural protection for this infrastructure. And here at Pensacola Beach, when we turn the cameras around, you'll be able to see the land side of the beach. But we have a lot of erosion. It's, again, it's part of the process, but you want to have healthy dunes, and these are eroding. You can see we don't have a long, wide stretch of beach between the dunes and the open Gulf. And you see sand piling up. You see it coming down off the little cliffside there, and it's just not a stable, mature dune anymore. It's damaged. So what do? There's a few things you can do to try and rebuild dunes that have been impacted from storms or from heavy erosion. Escambia County has invested in some beach renourishment projects. Some of these are, most of these are grant funded, but they are very, very expensive. In the last 20 years, we had a major beach renourishment project that basically go offshore. They find sand that matches our pretty white sand, and they dredge it offshore, and then they pump it back onto the beach. And they use, like you see, these bulldozers to kind of move it back in place, try to form some artificial dunes that can be planted later. But so we did that in September 2003. So there was an 8-mile stretch of beach where they renourished it. Well, if you lived here long enough, you know that exactly a year later we had Hurricane Ivan come in and pretty much wiped out that renourishment project. So that's the risk you take with renourishment, right? You spend a lot of time and investment and manpower, and then here comes Mother Nature. So in 2006, they were able to do the same thing. They started with 4 million cubic yards of sand. I think the next time they had almost 3 million cubic yards of sand they replaced in that area. Renourished the whole 8-mile stretch between the Nashville seashore. And then in 2016 was the most recent renourishment project when they put another 2 million cubic yards of sand out on these beaches. I'm not sure what the next plan is, if there's another one intact, but it's been about every 10 years. So we'll see if there's more of that to be done. Other efforts that have been done, this was a school group that went out and planted sea oaks right in Casino Beach in the central part of the island. You have homeowners who will do this. You have private companies who are contractors that will come out and plant sea oats and other native vegetation to try and stabilize these dunes. Sea oats have long, deep, stable root systems as long as they're not disturbed, and they anchor the sand in place. They are the only thing keeping this sand from just washing away, from being any different than a sandbar that's out in the Gulf. All right,
question break. Yay, get your questions in, everybody. Yes, very exciting. And actually, before I get to anonymous attendees question, just so I can summarize for my own learning. So erosion, it's when the sand basically leaves, right? Yeah. Okay. And I remember when Carrie and I came out here for the first time, I didn't know what dunes were actually supposed to look like. I thought the dunes we were looking at were perfectly fine, but they're not supposed to be cliffs like the ones we're about to show you, or like the ones you saw on your last slide. They're supposed to be like what Carrie showed you, where they're sloping, right?
Sloping and vegetated all the way down.
And the reason that's good is you said the sea oats and other vegetation, they just keep the sand from leaving.
Yeah, the roots hold it. They form basically a network that keeps that sand intact. Because otherwise, it's very erodible, big grains of sand that just move and blow. And so, without the root system, off we go.
Yeah, and if without the beach, we just have ocean, right?
Yes. We just have open water, and the buildings are kind of left to their own devices.
Yeah. So you want a beach, otherwise your building might be in the water.
Yeah. These are our natural fortresses that protect the city of Pensacola for us.
Got it.
And we go straight into the bay. Off we go.
And it's just a beautiful place to be, everybody. I think the beach is worth preserving in its own right. I had a lovely day here today. It's worth it.
Yeah.
Okay, so anonymous attendee wants to know, are there any non-human factors contributing to climate change?
Not this rate, right? I mean, climate over millennia has changed, but this rate is directly tied to the Industrial Revolution and to the use of fossil fuels. I have a copy of a 1900 Popular Science magazine where they predicted this. They talked about how the extremes of carbon dioxide and methane that are going up into the atmosphere are going to create a blanket that keeps the planet warmer. And in the next century, we'll see the impacts of it. So it's something we've seen and we've been able to tell is directly tied to it. Of course, there are temperature fluctuations. But again, this climate and this intense change is human caused.
Yeah, we sped it up way too much, everybody.
Yeah.
By burning fossil fuels and living the way we have. We've heated up the world, as Carrie covered. We've melted the ices. The sea levels have risen. And then we end up with our infrastructure stress. We end up with things like erosion on the beach due to sea level rise. It's a problem. Like we just said, if you lose the beach, you just have water.
So, and the water's nice, but
yeah,
it's nice to stand on.
I like it when my buildings don't have water in them. Yeah,
for sure.
Definitely. So it's a safety issue too. So the thing we talked about, the adaptations you can do, like beach renourishment, so adding more sand, planting vegetation, making the dunes more resilient, less likely to go away. All of those are important options. Christopher was talking about other reasons that there can be increased rainfall intensity and durations. I mean, the different causes of climate change, the human actions and like the natural stuff going on. I mean, it still leads us to the stressed infrastructure, right?
Yeah, we can handle the natural variations, right? It's that continued stress that we keep putting on it that's problematic.
Exactly.
That we can do anything about, right? There's nothing we can do about a volcano or a wildfire necessarily that's naturally occurring, but the things we can impact are the man-made causes.
We can turn the volume down on our end to reduce the stresses to our infrastructure.
Yeah.
So I have one question. So I've been enjoying my time in Pensacola, and I was thinking about if I was someone who just like lived in an apartment in downtown Pensacola, why would I care about erosion on the beach?
Well, the tourism dollars that come, and the reason that those beach renourishment projects were approved is because tourism dollars are a huge industry in Pensacola, Escambia County area. People who come to visit our community, who eat in our restaurants, and shop in our stores, who stay in the hotels. These provide jobs, these provide businesses for locals, and so it's a huge part of our income for our state. Tourism and agriculture are the biggest things in Florida. And so even if you're not in the tourist industry, even if you don't like coming to the beach, your taxes and everything are supplemented tremendously by people who visit here. And, besides, most people who live here come out for some reason or another.
Yeah.
And of course, the wildlife, the seafood, all of those things that are, the endangered species that are out here need these beaches.
Yeah, it's all part of the ecosystem here, definitely. And that's a great answer. So even if you hate sand and you never want to come to the beach, it's still worth preserving. Those tourism dollars matter.
Yeah.
All right, last chance for questions, everybody, before we get to our demo. So exciting. Last chance for questions. We'll have another question break too after the demo. I'll ask a quick question to Carrie. What's your favorite part of living in Pensacola?
Oh gosh, there's always a festival.
Yeah.
There's always something to do. The weather is, for the most part, pretty great. Seafood's amazing.
It really is.
Yeah.
I ate at Peg Leg Pizza earlier, I'm not ashamed to say, and it was delicious.
Shout out to Peg Legs. We're right across from it now.
That's right. That's where we are today. All right. Well, I think it's demo time. So let's get in there and we're going to see erosion up close. So I'm going to stop sharing my screen here. And everybody, if you stop hearing us at any point, my mom is pivoting. My mom's our camera woman today. She's pivoting the camera to go look at the dunes. There it is. So Carrie, what are we looking at there?
So we're looking at some pretty severely eroded dunes. An ideal barrier island dune is going to have vegetation all the way down the front. It's going to be a gentle slope. It's not going to be that steep drop. You're not going to have that loose sand that you see right there in the foreground where it's just kind of coming down, sheet flowing off the edge. You're going to have healthy vegetation that comes down all the way to the open beachfront. You see these roots are just, they're long and they're trying to hang on, but they are literally falling apart. These plants are tumbling off the face of this dune. And so, they can't hold on if they're being impacted like this. And when you have higher seas, the storm surge goes in quicker, flooding comes in quicker. And I just saw some sand sort of tumble down there. That's just with the wind.
In real time.
In real time, yeah.
We had some sand tumble down.
Yeah, and so that's just, it's just going to fall. And then if you have, somebody, we've got spring break coming up in the next few weeks.
Oh, I saw some people climbing the dunes earlier.
Yeah, 100%.
Yeah.
If you have a group of kids try to race each other up here, that whole sheep face of that dune is going to fall down. The plants are going to follow it, and it's it's going to be gone.
Yeah.
And then you just have I don't know, 75 yards between here and the road, maybe. And so again, you've got vegetation up there. This could be before in an area where there's not been a hurricane, you might have a 30 or 40 foot dune. But when you have a hurricane hit, they start dropping. But they can slowly build back. But they can't build back if they're being impacted or if, the open sea is too close to them. Or if you have people climbing around on them. So while those sea oats can hold the plants, can hold the sand intact, and the other vegetation, there's like 40 native species that do this job, and sea oats are the most obvious. But those root zones and those fibrous rhizomes that run through here, you can see crisscrossing around there, hold it intact. But if you hit it and you start punching into it, it falls apart and it's just gone.
Oh my gosh. So these dunes were bigger at one point.
Oh yeah.
Okay.
Yeah. Before, some of the big storms that we had, it was big storm in the 70s.
Yeah.
Another series of them in the mid 90s, mid 2000s. So yeah. But if you go further down to Fort Pickens, you'll see some more that are intact.
Yeah.
They're not as impacted, and the dunes are on the other side. We have some on the other side of the road. They're a little more stable. But yeah, these get a lot of traffic. They're right next to an actual walkover and a kind of made up walkover where people just cut through and make a little rabbit trail.
We'll call that an illegal walkover.
Illegal walkover, and so that's the first place that storm surge is going to blow through when a hurricane comes, and you'll have a split, and you'll knock down a dune where you have those little homemade trails through there.
Yeah. Well,
but yeah.
Wow. I mean, it's also interesting, even just walking down the beach earlier today. I mean, this one's really egregious, but there were healthier dunes even further down. I guess there are like levels to this.
Yeah, absolutely. It doesn't happen, necessarily overnight. It's a slower process.
Yeah.
But these kind of sheer cliffs that we're getting are certainly problematic. That's classic kind of canyon-like erosion, right? Like you'll see out west. It's the same process. But these sands are really, really erodible. There's not a lot of organic matter to help hold it intact besides the plants and anything that they're adding.
Yeah. Well, thank you, Mom, for today's demo. We'll go back to our stand. We appreciate you. And thank you, Carrie, for explaining all this to us.
Yeah.
Anika has a question about it. She said, wow, that's a lot of erosion. Yeah, it is. Anika wants to know, do you bring in more sand to build it back up? What's the best way to build back and stronger?
So, yeah, I mean, if somebody were to attempt to repair this, right, I think ideally I haven't done a dune restoration project personally, but what I would presume is that you would have to bring in some sand, and like you do with a living shoreline, you sort of slope it, right? So it's sort of natural, and you plant vegetation back into those areas to fill it back in.
Yeah.
So it's a more natural grade, and it's not that steep slope that we're seeing. You want it to kind of carefully make its way down and have vegetation throughout it to keep it intact.
That's awesome.
Yeah.
I actually did an event recently in Cape Canaveral. They had a bunch of volunteers come out and plant sea oats.
Okay.
It was pretty cool.
And it's neat the way those sea oats will work too. You probably planted them, kind of buried them down. Like, so most plants you put the plant at the surface of the soil because you don't want to deprive it of oxygen. But sea oats, they're stimulated to grow by the movement of the sand. So you put a sea oat, 6 inches down into the sand, and then as sand blows up against it, it stops, and it falls at the base of the sea oat plant. Yeah. And then it starts to make a little mound, and then the plant grows up higher to get above that mound. Yeah. And then it stops and accretes and accumulates more, and then you have the dunes. Got it. So it's a slow process, but that's what happens. That's how it works.
That's so interesting. It's so interesting how plants perfectly evolve for their environment.
Yeah. This is a desert. I'm surrounded by water, but on this side of it is desert conditions. It's sandy, it's salty, it's full sun, it's hot. We have literal cacti growing out here. It's the same kind of conditions.
Wow.
So they're very tough plants.
That's really interesting.
Yeah.
I've never thought of the beach as a desert before.
Yeah.
Fascinating.
Yeah.
Cool. Well, you all got today's demo, and feel free to get any other questions in there. There's still time. Yes, we love hearing from you, so get your questions in. I have one more question about the vegetation we're seeing. So we've talked a lot about sea oats. What other vegetation would you recommend planting to help, decrease erosion of dunes?
Right. So there's a lot of vines that grow, railroad vine, Nicomia. You've got beach honeycomb head, which is a small little plant that has yellow flowers that attract a native bee. It's only found in this ecosystem. You've got blue stem grass. You've got several kinds of rosemary. Again, I mentioned the cactus. There's a lot of little grasses and flowering plants that grow well here.
Interesting.
Yeah.
That's awesome that there's so much diversity.
Yeah, there really is. It looks kind of uniform, but especially once things start to bloom in the spring and fall, it can be quite colorful out here. Flowers and purple and white and yellow everywhere.
Oh, I'm gonna come back. I'm
Yeah,
excited.
you'll see the oats. Actually the seed heads on the sea oats. This is beach mouse habitat. We've got a little endangered species of mouse that lives on Perdido Key, and it's not endangered on Santa Rosa Island here because this is a long contiguous area, but that little mouse moves seeds through and helps repopulate the dunes.
Yeah.
It's been the bane of a lot of people because it can limit development, but that mouse helps spread this vegetation that you can see is crucial to the area.
I think that could be a campaign. Save the sea mice.
Oh yeah. The beach mouse. There's a lot of work and education that goes into that. They're cute little, they blend in with the sand, little bitty guys.
That's a good mascot right there.
It is. Yeah. The National Park Service has magnets with the beach mouse.
Fantastic.
Yeah.
They beat me to it. Okay.
Yeah.
Steve wants to know: is there any current legislation to limit building along the coast on the little unbuilt land left?
So there are, theoretically, there's the Coastal Construction Control Line, the CCCL, that says you're not supposed to build gulfward of the dune lines. You're supposed to build behind that. And for the most part, Florida tries to enforce that. As you can see in that Alabama example, they're not doing that.
Yeah.
Right. And it would be helpful if the entire Gulf Coast could do it. Right. There are bigger land development plans, and we're lucky here in Escambia County because we have a lot of conservation land. We have the National Seashore that borders both sides of our core beach area. And I know a number of the developments here try to be good neighbors. They try to use native vegetation. They try to use energy efficient construction, that sort of thing. But as far as statewide legislation, it's kind of hit or miss. It's got to be, you got to have a critical mass of legislators pushing for that. And from what I hear, things are not really slowing down in Miami, and it's as flat as can be and rising fast. So, it's crap.
Definitely. And speaking of Miami, we're going to be down there on Thursday for ClimateCast Live, so y'all can tune in.
Yeah.
We have another question from anonymous attendee. They want to know, how does erosion impact animals? I mean, they just lose their habitats, right?
Yeah. So, probably the biggest and most sort of charismatic species that you'll be impacted are the sea turtles. We have 5 species of sea turtles that nest on our beaches here, and they need a wide, big beach to nest on. If it's flat and it's skinny, they're not going to have anywhere safe for their to lay their eggs. So when they come in and starting this summer through fall to nest, if they come up on this beach, they'll crawl as far as they can, but they're not going to get over that dune. So they may, but then if they try to dig at the foot of the dune, that dune may start collapsing on top, right? Kind of bury the sea turtle nest. So they're a really important species, or set of species that need this wide beachfront. There's plenty of crabs and shorebirds. There's a number of endangered shorebird species that use this swash area where the water comes in and by. You can probably see them running around and flying behind us, but they fish and forage in those areas. So particularly seabirds and sea turtles are going to be your main wildlife species that need this area.
Got it.
And of course the beach mice.
Yeah, we mentioned the beach mice. Gotta save the beach mice.
That's right.
So we've thoroughly depressed everyone, I think. And we have these sea turtles to worry about, these beach mice, and let alone ourselves and our own selves. And we did that demo, and you were able to see the erosion firsthand. So we've already taken lots of questions. So let's get into it. Let's Carrie, undepress us. What can we do?
Okay, so there are people out there working, right? So you got the next generation here who are planting dunes. These are some of those variety of really beautiful species of plants that will grow alongside the sea oats. And if you're interested in the other species and how to specifically go about it, my colleagues with University of Florida and the Milton campus put together this dune restoration and enhancement for the Florida Panhandle. You can send that link out, or you can just Google that title. It gives you step-by-step how to grow these plants, how to plant them, where to plant them, how often how to take care of them, and goes very in depth. So there's a lot of work in science on how to restore these dunes, because they will continue to be impacted both by storms and by man-made disasters. And so learning how to grow them, protect them, and keep them intact is huge.
Yes, so everybody volunteer, plant some native species.
Again, these barrier islands are our first line of defense. So I think, if you see an area like this, your kids are like, I want to climb up it. Tell them no, because it's going to just collapse. You're going to just have a whole, sediment delta down here, and the dunes are going to be gone. And, it's just a mess. So leave them alone. Look, they'll touch. Oh, there's a piece that just fell right behind us.
Oh my gosh, we just watched a huge piece fall down, everybody.
This is just wind blowing this down, right? And so even when you're not touching it, it's doing this. So imagine what'll happen if 1,000 kids come down this beach.
Do not let your children climb on the dunes, everybody.
Right. And again, don't be a jerk at the beach. Respect these areas. Use these walkovers. You will see areas that are closer to where you parked your car. There's just a little rabbit trail through the dunes that somebody's walked through the sand. Don't use it. Leave it alone. Let those plants grow back together so they're not a vulnerable area. Use the dune walkovers. They're every public area has one. And so protecting that vegetation. There are fines for removing sea oats. I think it's something like $500 if you get busted removing or damaging sea oats.
Yeah,
so,
it's pretty pricey, everybody.
Yeah. Over in Perdido Key, Barrier Island over near the Alabama border, we have a demonstration garden at the Perdido Key Visitor Center. So if you're ever in that area on vacation, even if you're in South Alabama, just come over the state line. It's also the fire station, but there's a really cool demonstration garden that has a lot of the coastal vegetation. Some of the things listed, you ask what other plants grow here. The blue stem, the cordgrass, railroad vine, all of these things are beautiful flowering plants or provide wildlife food, and they are adapted to full sun, open sand, constant salt spray. So if you live in a coastal area, you can learn how to landscape in a way that protects this area and provides more habitat for wildlife.
That's beautiful. Well, and also, Carrie gave you some great things you can do on the topic of erosion. I also, for those of you who are just nervous about climate change in general, in addition to the specific hazard we spotlighted today, which is erosion, there are a lot of other things climate change does that impacts our life. Beyond just sea levels rising, causing erosion, damaging dunes and our natural infrastructure, climate change can have extreme heat. So, it can make you more likely to get sick from heat stroke, for example, because of rising temperatures. Or, we mentioned, sunny day flooding. There can also be drought. Drought's a really common climate hazard. There are lots of different ways that climate change can impact your life. And you can document it through citizen science. So really quickly, what is citizen science? It's a collaboration between researchers and those of us who are curious, concerned, and motivated to make a difference. And citizen science goes by a lot of different names. You can see some of them on the screen, but ultimately, it's a partnership between anybody and everybody from any background, at any age, anywhere in the world, and a scientist to do real science. So usually you're collecting or analyzing data for research projects, and data is just information. Data can be numbers and measurements. It can be inches of rainfall, or it can be a temperature measurement that you might take. Data can be when you use a water quality test kit and you test your local water quality. Data can also be words and pictures. You can take pictures of different plants and animals, and by documenting those different plants and animals, you can send them to scientists and help them understand the species distribution so they can know if those animals might be endangered, for example. Citizen science is a really diverse field. It's any way a member of the public can have an impact on science in a real way. And I'm getting on my soapbox for a second, but why do citizen science to address the environment and climate? Well, I know I'm personally scared of climate change. I was looking at these dunes and getting really sad while Carrie was talking today. And I was thinking, the first, knowledge is power. So there are things that you can do, like Carrie said, in terms of planting native vegetation and not being a jerk at the beach, right? But you can also help understand the problem better by documenting it. And documenting it through citizen science is something anybody can do. I'm probably going to take a picture of this erosion later today and send it to a citizen science project to document that climate change impact. And I think it's really important for all of us to do citizen science to document climate change, because climate change is hyper-local. Carrie was talking about flooding earlier, right? Well, the way I experience that climate impact may be different than my friend across town. Maybe I live a few feet above sea level, so my street's less likely to flood, whereas my friend is dealing with water in their driveway. Maybe I have more trees on my street, so it doesn't get as hot where I am, and I'm less likely to get heat stroke than my friend across town. It really just depends, and we can document those hyper-local differences through citizen science. So when you feel powerless and scared of environmental problems and climate change, hopefully citizen science and that knowledge-based understanding can help you take that power back. And once you have that good foundation of knowledge, you can do other things too, like Carrie mentioned, to help adapt to climate change or even reduce it. And that's called mitigation. So the project I wanted to spotlight, this is an affiliate project of SciStarter, which is one of the supporters of today's program. It's called IC Change. So IC Change is actually separate from Extension, but it's a project that agreed to partner with me for my PhD research. IC Change is basically a global project that turns anybody and everybody into a climate reporter. And the reason I spotlighted it today is because it's really simple. You literally just take a picture of the climate impact you see and you send it to IC Change with a description of what you think it's going to happen to you based on the climate impact, or what you think will happen to your community. So you're giving your own perspective, and your perspective is what we call qualitative data. That's your assessment, your words, and then you send those pictures. Words and pictures are qualitative data. And then that qualitative data is paired with quantitative data. So you see here was an observation of flooding and an assessment of the community impact that someone sent in. And that was paired with the numbers, the quantitative data, the inches of rainfall, the temperature that day. And the combination of your words and pictures and assessment, your lived experience with that quantitative data helps us really understand climate change. And then once we have that full picture, we can target even more infrastructure developments and help make us safer and help us react better to climate change. So I would love it if you all participated in IC Change. You make an account, and if you make your IC Change account with the same email address you used to make a SciStarter account, it all tracks back to your dashboard. Just wanted to say that there because I'm a big SciStarter fan. Then you can post your sighting, and then you can also browse other people's sightings. It's a very accessible platform. And after you do today's survey, if you want to do an interview with me, and it's all going to be in the follow-up email for this, if you're interested, you can share your screen and tell me why you chose to submit what you did to IC Change. And it's super simple. And also, I hope you keep on participating in citizen science. This April is Citizen Science Month, so you can participate today, but participate again in April. And if you do, you'll be included in the 1 million acts of science. We're trying to get people to submit 1 million data points to different citizen science projects. And taking a picture of a climate impact of IC Change and submitting it is indeed an act of science. So I really hope you all do that in addition to the calls to action that Carrie gave today. So we only have a few minutes left. It's your last chance for questions, everybody. Last chance. I have one question for Carrie while people get their questions in the Q&A. So we gave people a lot of different things they could do today, you know, planting native plants, appreciating their local beach, going to a demonstration garden. If people only have time to do one thing, what do you recommend?
As far as like visiting the beach, again, using the dune walker overs and respecting these existing intact dune systems and telling your friends who are visiting from out of town how important they are.
Yeah.
I feel like locals may appreciate it and visitors may not understand the full importance of why these dune systems are so important.
Yeah.
So letting people who come to see you, who live on the coast, explain to them how important it is and educate them.
Definitely. If you don't have time to, you know, volunteer and plant native vegetation, that's a no-brainer.
Yeah.
Just don't cause the problem.
Yeah. Just don't make it worse.
Yes, there we go. If we can all aspire to do something today, it's not making it worse.
Yeah.
That's today's takeaway message. I appreciate it. That's good. That's really good. All right, last chance for questions, everybody. And while you get your final questions in, Carrie, is there anything else you haven't had a chance to tell us today that you think we should know?
Well, I think we've covered it. You know, come out and enjoy the beaches. You know, carpool on your way here. Ride your bike. Take the ferry. But protect them and value them and understand that these barrier islands have an important job to do and respect those.
Definitely. All right. Well, there is a survey, everybody. I know everybody loves surveys, so I'm gonna. But please do it. It'll help my PhD. I'm gonna go ahead and put the link in the chat for everyone, so they can help me if they so choose. If you are kind enough to do so. So it's bit.ly/ClimateCast survey. Not to be confused, there might be some questions that pop up in the Zoom. Those are not the PhD research survey. Those are just some questions that I wanted to know on behalf of Extension about today's program and online programming versus in-person programming, because Extension does so much in this community. If you go to the Escambia County website and you explore all of Extension's programs, I mean, Carrie's running the billion programs. You got the Master Naturalist class coming up. Yeah. All sorts of different things. And like we said earlier, after the survey, you can also interview with me and tell me a little bit more about what you learned and what your assessment of the environment and climate change is. And you can show me what you participated in with IC Change. And then, Carrie, take us home with our final resource roundup.
Oh, yeah. So these resources are some that I have used and referenced in this talk. So the Coastal Erosion Climate Toolkit, the toolkit.climate.gov. This is a federal government. It's a NOAA resource. It's got a lot of great information on coastal erosion, climate impacts, that sort of thing. That dune enhancement, the details on the plants and how to restore dunes is there at that EDIS link. Article from Chris Moody with the Washington Post that specifically mentions the increase in sea level rise off the coast of Pensacola and in the Gulf of Mexico that links directly to the scientific studies that are being done on this. If you want to understand more about what's causing that and what they're looking at prediction wise, and then the NOAA site that just every year I see this. 2023 was the world's warmest year. Last year it said 2022. Before that it was 2021, 2020. It's continued to go up.
What do you think will happen this year?
Oh, I mean, it'll be a big surprise if 2024 is not the world's warmest year by the end. But we can hope. But again, these are great scientific websites, great sources that'll give you real information, fact-based, just explain it really well, good pictures.
And we'll be emailing those out, everybody, and they'll also be listed on the ClimateCast website. So that's all, folks. Don't forget to do that survey that's linked in the chat. For those watching the recording later, you can do the survey too, at same link. And I just want to give a big thank you to Carrie for teaching us today. I learned a lot. I hope you all did too.
My pleasure. Thank y'all for attending and participating.
Woo, that's all, folks. All right, so we'll stop sharing here. If we can find my mouse. Where'd it go? Come on, you can do this. There it is. All right, well, everyone, we hope you have a great night. Thanks again, and I hope to see you all on the beach, not crawling on the dunes using the walkway. All right, bye, everybody.